Okay, we're going to just jump right in. We're going to talk about graphing systems of inequalities. Okay, graphing systems of inequalities. But this is different than the last homework because the last homework was just graphing inequalities, not systems of inequalities. Systems means more than one inequality, right? And we're going to graph them on the same graph. Okay? However, the first type of question you could get would be something that where you don't actually graph. It just says, tell if the ordered pair is a solution to the given system. Where is the ordered pair in this problem? What is the ordered pair?
2, 7.
Yes. That is an ordered pair. I don't know if you guys know that that's the term for that, but that is an ordered pair. It's also a coordinate point, right? It's called two different things, either coordinate point or ordered pair. You're ordering the x and y in a pair, right? Okay?
And make sure to give it a hug.
And we know, is 2x or y?
X.
2 is x, and 7 is y, right?
Yep.
We know that. So how would I find out the answer to this question? So Dan, what would you say?
So if 7 is y,
Talk a little louder.
so if 7 is y,
Yeah.
I would replace the y's.
Okay. So let's use this. Let's use this one. We got y is greater than x plus 5. So if y is 7, I'm going to replace this 7 with, this y with a 7 is greater than x plus 5. 2 plus 5, which is 7.
So it's incorrect.
Y is greater.
Is that true?
No.
That is not true. If it had said equal, greater than or equal to, it would be true. Immediately I can stop. And I can say,
No.
no,
No.
it isn't. Right? Because I just tried it and it didn't work. Now, let me give you another point. Okay? Now we're going to do the same thing again. I'm going to give you a different point. All right? Let's say I said 110. Okay? So let's try it. Y is greater than x plus 5. Y is 10, right?
Yeah.
This is my y, this is my x. So 10 is greater than 1 plus 5.
Yes.
So 10 is greater than 6.
Yes.
So what is my answer to question number 1?
No, you don't. Well, so you don't know yet because you have to do the second one as well.
Yeah.
Yeah, to see if it's true.
Why would I have to do the second one?
Because
It's because it might be true for the first equation. But
Ah,
the first
right.
inequality, but not
It
for
could be
this.
totally true for this one, but not true for this one. In order for it to be true for the system, it has to be true for both of them. So I've got to try it on both of them. Is 10, now I'm going to do this one. 10 is 10 less than 4 times 1 minus 1. Is 10 less than 4 minus 1 is 3? No. So it is not a solution. So no is the answer. No, it is not a solution. Does that make sense?
Yeah.
You get
7
it?
is less than 3.
What?
No.
No, it is not less than 3. Right. Okay.
Specific?
Pretty clear, right? You're just using algebra, substituting the x and y in of your ordered pair.
We have homework.
So that's the first type of problem that you'll see on the homework.
Oh, that's easy.
That's
We
easy.
should start with like a little note like that.
Can that just be all our homework?
The second type of problem you're going to see is something like this. Graph.
What?
Y is less than 4 and y is greater than or equal to 2x plus 1. All right?
Gotcha.
Okay? So I have two equations. Let me just quickly get.
Wait, so, Skip,
Yes.
what do we do?
I'm going to do this in red, okay?
What do we kind of do the same thing?
And I'm going to do this in green,
Why?
okay? So what we're going to do is we can't substitute anything because we don't have an ordered pair. We're being asked to graph this. So I have to actually get a graph paper. Put a coordinate plane out here, right? And this is my y, obviously, and this is my x. And 1, 2, 3, 4, 5, 6. Okay, so I'm going to graph the first one first. How would I graph y is less than 4? Mushi, what would you say?
Why is less than 4?
Yeah. How would I graph that?
Oh.
I already asked you. You don't have to raise your hand.
Brain.
I know, it's tricky, because I haven't done these very often. I'm asking you because I want to see if you remember.
Graph is just a line.
Yes, exactly, right?
I told you.
When there's no x at all in it, it's just a y. Think of it as always. Y is always less than 4, no matter where you are on the x-axis. Y is always less than 4. So if I was over here, I would be at 4 over here, right? If I was here, I would be at 4 here. If I was over here, I would be at 4 here. And y is, would this be a solid line or a dashed line?
Solid.
Dashed.
No,
The D
Oh,
dashed.
dashed,
Yeah,
because,
it'd be.
Right, this is a dashed line, right? It does not equal this line. This is just a boundary line.
I forgot what dash meant for a minute, I remember now.
Yeah. Okay, so it's a dashed line. Now, where would I shade?
Because it's hard to for 2 days.
How would I know which day? So, James, how would I know which way to shade?
Because, how would you know? Because there's dots guiding you? Oh, which way? Oh, because.
I gotta know where to shade.
If it's a, if it says it's greater than, then you would put dash. If it's like, if it equals, that means it's a solid equation and you
Right.
put a line.
Right.
Which
Right.
way do you shade? Oh, which way?
Yes.
Yeah. Do I shade
Oh.
below or do I shade above?
Oh.
Why? Why is less than 4?
So down.
I would shade. What
Away
is
from
less than
what?
4? Is 0 less than 4?
No. Yeah.
Yes. So I would just still try my 0, right?
Shade down.
And I would shade down. Now, this is my suggestion, and this is where I want you guys to just watch for a
Sorry,
second. Jan, I want you guys to see this.
Ready.
I'm going to suggest that instead of shading the whole thing right now, do this. We know right now, I now know how I'm going to shade this line, okay?
Yep.
Okay.
Okay? Now my second line is going to be my green one. Okay, let's do this. So, how would I graph this?
Well, you just do
So,
it like a
yeah,
regular one. So
Rosemary.
you go.
Rosemary.
You'd go up 1,
I go up 1 and I put a dot.
and then you'd go up 1 and over 2. And
Right?
up 2 and
Rise
over
to
1.
run 1. So I rise to run 1 and I put a dot.
Okay.
Draw your dot.
Rise
full
1,
line.
rise 2, run 1, put a dot.
Draw
Solid
your
line.
full line.
Okay, is it a solid line?
Yeah.
Okay. Whoa, lovely line.
That's a great
Oh,
one.
that's like my line.
But do you put arrows on the end of it? I never.
Technically you do, but oftentimes you don't see them with inequalities because you're so busy shading, right? But they are going on forever now.
Gary, you made it a habit of mine to always draw arrows.
Yeah, it's good.
On solid.
It's a good. I probably should have on those two, but I didn't. Okay. Now the question is, where do I shade?
You're going to shade.
I'm going to try 0, 0 again. Is 0 greater than or equal to 0 plus 1 is 1?
Nope.
No.
Shade away.
So I'm going to not shade towards 0, 0. I'm going to shade away. So I now know I'm going to shade like, let's see here. See now look, I know I'm going to have to shade that way, right? But now look, I'm looking at these things. This one I'm going to have to shade this way, I think. Therefore, I'm going to shade this one away like that, right? So watch, this is what will happen. By getting them going like that first, you know exactly how you're going to shade this thing. Now, I could keep going, right, here, but I know my answer is going to be this little triangle. Does that make sense? Right? My answer, I could have kept going, but it's going to
What's
be,
your answer? Triangle.
so I'm going to shade like this,
Oh, fancy.
right? Do you guys see that? Now, yes, I could still shade over here, and if I wanted to, I could,
So we're getting into shapes now.
but notice, what's the difference? If I had kept going with my green, right? I don't usually like to keep going with my
It
greens and my
doesn't
reds
look nice
It has
anymore.
to be where it both.
because it has to be where they're cross-hatched. Does that make sense? It's where they're both true. This is the only place that they're both true. And of course, this triangle keeps going forever and ever in that direction, right? See what I'm saying? Right? It's going to get bigger and bigger and bigger and bigger, and it's forever. There's an infinite number of solutions. Now, what if I asked you, give me 2 points that are in the solution area? 2 points, Jan.
Negative 9, 0, and
Negative 9, 0, and what? Negative 10, 0, right? Those are definitely going to be in that area, right? All right, so Luke, give me 2 points that are not in the solution area.
negative 2, 0.
Well, but that's in the solution point.
Oh, out.
Yeah, that's not in it.
Oh, 10, 0.
Yeah, 10, 0, 11, 0, or 5, 4,
0, 10.
0, 10, 0, 10, exactly, right.
10,
Exactly.
0.
10, 0, right? Fist of 5, do you understand this? All right, so the whole first page of the homework, 2 sides of a page, are just problems like this, okay? Did you understand why I suggested you put tiny little shading first?
Yeah, to show where you were
Because
shading.
I don't want to do this. If I had a line here and another line here, I wouldn't want to do this. Do you see why? I wouldn't want to do that. See that? I want it cross-hatched. Does that make sense? And I also kind of don't like to make them parallel to my x and y axis, because then I could draw over my x and y axis and then I couldn't see it. Does that make sense? So I kind of like it to be somewhere in between. And the idea is to, to just make it as clear as possible of what the answer is. Does that make sense? Okay, now the second homework, the second sheet, is talking in particular about parallel lines. Okay? Parallel lines
Parallel.
with,
Manipulate things to make parallel and what's the other one?
but we're talking about systems of equations still,
Oh, okay.
or systems of inequalities. But I didn't really talk about this with systems of equations. But what if I did this? What if I gave you,
Is this a new problem or?
yeah, you don't even have to write this down. Just watch this for a second. If I gave you something like this, if I gave, I'm going to do an equation, not an inequality, okay? What if I gave you y is greater than, well, no, not greater than, let's do an equals first. Y is equal to 1/2 x plus 2, and y is equal to 1/2 x minus 4. That's a system of equations.
You're insane.
What will the solution be? What do you immediately notice?
That.
What do you notice that's the same about those two
They both
equations?
have 1/2.
So, 1/2. What is the 1/2?
Rise over run.
Rise over run. Rise over run is called the
Slow.
Parallel.
They are parallel. And what are you trying to find out? What are you trying, guys, listen, this is really important. What are you trying to find out when I ask you to solve the systems of equations? What are you looking for? Well, of an equation.
Both of them are true.
When you're solving systems, back like last week,
You're looking for areas where
looking
both of
for-
them are true.
you're looking for where they cross, right? Well, what if they don't cross?
They're
What if they're
parallel.
parallel? What's the answer?
No solution.
No solution. No solution. Does that make sense?
Yes.
Right? You guys hear this? You guys making sense? No solution? Are we passing notes and stuff in my class? Is that what's happening? What's happening? Just so I know. What's that? Whose is that? Is that yours? Oh, okay, great. Thank you. So when we have parallel lines, come on guys, don't interrupt me, please. When we have parallel lines, there's no solution, right?
Yeah.
To the system. What if the parallel lines are the same line? What's the answer?
Infinite solution.
Infinite solutions, right? If I gave you two equations, y is equal to 1/2 plus 2 and 2y is equal to 1x plus 4, right? Those are the same equation, right? I just changed them a little bit. They would be on the same line. There would be an infinite number of solutions. Does that make sense? When they're parallel, though, there's no solution. Now, that's not true with inequalities. Okay, with inequalities, let's say I gave you something like this. I should have just kept that. But y is greater than 1/2 x plus 2, and what was the other one I did?
1/2 x minus 4.
Okay, we'll do that, okay? So we're going to still do this with different colors, okay? That'll be that, and this will be this. We've got the wrong colors on these caps. Jeez. Okay, so here we go. Let's see what happens when they're parallel. Okay, for the red one, what do I do?
Oh,
Plus up 2.
Up 2,
Over
1, 2, put a dot.
Rise
1
one.
over 2.
Rise 1, run 2, somewhere around there, right? And then it's is it a solid or dashed?
Salt dash.
Dash.
Dashed. So I'm going to do a dashed line like this. Okay, now which way am I going to shade?
You're going
I'm going to try 0, 0. Is 0 greater than 2?
No.
No. So this is not a solution. So I know I'm going to be shading up. You with me?
Yeah.
Okay, my next line.
Oh, and it's going to be continually.
My next line is down 4. 1, 2, 3, 4. Put a dot. Right? I'm going to rise 1, run 2, put a dot. Right? I'm going to draw my line. Is it it's a dashed, right? Are they going to ever cross?
No.
No, they're never going to cross because they have the same slope.
Never, never, ever.
Now, which way do I shade? Is 0 less than negative 4? Is 0 less than negative 4?
Yeah.
No.
So this is not a solution. So this one I'm going to shade down.
So they go apart. They go like
So they're going to go apart. So let's see. So I'm going to shade this one like this. Right? I'm going to shade this one like this.
Now there's a pathway for me to walk.
All right, what's
Yeah.
yes,
Like a
exactly.
building, and then I walk. Now
So
it's like
what
a
is
road.
the solution?
No
Like an
solution.
alleyway.
solution.
Where the solution is where they
Me.
cross hatch.
So it's not
But they are
possible.
not cross hatching, and they never will.
Solution.
There is no solution. Does that make sense?
Gary, until they go all the way around the world and meet at the back.
All right.
No, it's still.
So now,
Still will never leave.
Yeah, James, they still won't ever. Yeah, they won't ever intercept. They can go all the way around the world and
They'll
connect to
intercept
their
and
own.
Jerry doesn't draw a straight line.
Well, also, they won't go around the world because Cartesian planes aren't on a sphere.
That's
If they
true.
were,
They'll
they'll
just
just
go
go all messed up. Yeah, they'll
Yeah,
just
they'll
go
go
infinitely on a plane.
so what if you had this though? What if you had this scenario? Okay, those are parallel. Gotta trust me. They're parallel.
I'm trying.
Okay, yes. All right, and let's say it said it's greater than this line. And then it said it's greater than this line.
Then it's infinite
Yeah.
above the place.
Is it half solution? I'm
So
not
it's
sure.
all, the
It's
solution
infinite.
is only
Yeah.
the part above the second line,
It's
the top
infinite.
line. Does that make sense? Because that's the only place where you have the cross hatching.
Technically,
Make
a perfect
sense?
solution would be infinite if you had one of those cross-hatching things. You
Now,
just
what if I
shade that
gave you
area
this scenario?
cross-hatch it.
What if I gave you this scenario?
So then the solution would be above the red line.
Yeah.
What if I gave you this scenario where it was below this line and it was above this line?
That would be
So-
infinite.
It's going to be this way, right? And this way, right? So the solution would be only the areas in between those two lines. Do you see the difference?
Yeah.
So those are the kind of things you're going to be exploring in the homework on the second sheet.
So Gary,
And it is there would be an infinite number of solutions, but it would only be in this area. Does that make sense?
Wait,
Okay.
so Gary,
Yes.
for our homework, we don't need to come up with a specific point, right? We just need to draw it on the graph.
Can you remind me? I can't, let me just see. I can't remember if I did that or not.
Gary.
I said give two ordered pairs in the instruction that are solutions and two ordered pairs that are not solutions, okay?
Gary.
After you've graphed it. Yes.
So, if you weren't to give specific lines, it's only in that area. So what if you got infinite and infinite, so it took up the whole board, and then you crossed it? Then would it be a true infinite everywhere solution?
Great question. I'm going to turn this off before I have to answer